yesterday. I'm bragging. It was a lot of fun. If you have not done it, it's definitely worth trying. But yeah, my name's Keith Thomas. I'm with AT&T Cybersecurity. I'm the practice lead for our cybersecurity operations. I also have some experience in DevOps and DevSecOps. And so I was going to show you today a program or a presentation on how to use cybersecurity tools for your AppSec development in what we call a shift-left security model. And so I'll cover what that is as well. For anyone that's here, for the folks that are here, has anyone not heard of shift-left security? Okay, great. Has anyone not heard of Z attack proxy, OWASP ZAP? All right, so I'll cover, for those who haven't seen it, I'll cover what that is later in the conversation, but the idea here is that we're going to use OWASP ZAP and the OWASP Juice Shop as an example on how we would leverage shift-left security. Everyone in the room here is probably familiar with DevOps, and we all kind of understand the trend of this. The more of DevOps that you implement into your cybersecurity or into your development program, the fewer failure rates that you have. And so think about how software is developed, how it's created. Our developers, they go through a process of building the software. Someone tests it. Someone does like penetration testing to make sure that it doesn't have any vulnerabilities. And in a traditional model, like a waterfall model, that testing could happen further down. And so what we want to do is we want to shrink the amount of time that the developers get the information they need for vulnerabilities to make sure that they get that stuff addressed quickly and not have to wait until the application's in production before it gets tested. Shift-left security is about making sure that we have faster development, making sure that we have better collaboration between all of our teams. We think about our cybersecurity teams, we think about our IT operations team, we think about the developers, QA testers, project managers, the change control board, right? There's a lot of people that spend a lot of time helping us get our software out into a production environment. And so we want to make sure that we have that collaboration to support that, and that's another reason why shift-left security is top of mind. It also helps us fix defects earlier in the process. I mentioned that just a moment ago. Shift-left security gives the developers the information sooner in the development lifecycle so that they can deliver a less vulnerable application. It does improve security, right? So we always want to talk about how we improve security and reduce the vulnerabilities, and then making the software better or making the developers more productive and better at delivering. And also, as developers see things like these security trends that are happening, the information that they get from the security vulnerabilities that are being sent to them, it helps them get better at software or secure software development. There's quite a few different tools, types that are out there to help our developers get secure code delivered to production. And this is a list of the different tool types. So I'll start at the top here, static application security testing. This actually is where we're examining the code of the software and making sure that the code doesn't have any particular vulnerabilities that the developer may have accidentally put in. Software composition analysis. This is about looking at the code. A lot of our software developers will go out and download open source code from GitHub or GitLab, right? Some of the different repositories out there. And so what this does, it's designed to look at the code, recognize that that code is open source, and then it can tell the vulnerabilities of the code. But another really important aspect of this is certain licensing models in the open source world have different requirements. So some licensing models have requirements where if you enhance the code that you're using, even though you've downloaded it as open source, you're obligated to share that enhancement back to the community. So there's some licensing models that support that. other licensing models. They support you download the code, use it for free will, and do whatever you want. You do not have to contribute back to the community, or you're not obligated to contribute back to the community. And that's a really important factor because our companies go through software audits. I was actually at a company where we went through a software audit, and that's really time consuming. And come to find out, right, they ended up having to pay penalties to because they were using software inappropriately, or they weren't using software under the licensing model that they were supposed to. Dynamic application security testing. Yeah. Sure. Hang on just a second here. Is that better? Okay, thanks. Technical difficulties. Dynamic application security testing. This is what I would call your traditional pen testers, right? The folks, the application is live, it's working, and we're going to go and examine that application while it's in that live mode. And then runtime application self-protection. These are controls and features in the application that the coders have put in, or it could be features that are used from the operating system that the coders leverage to create a more secure application. And so you think about like logs that might get generated by the code, or if it sees an attack, like an injection attack, where maybe some weird character strings are trying to be inserted into it, it would recognize that and it can mitigate that attack on demand or in real time within the application. And then our web application firewalls, these two, we like to put those, a lot of times I put those in front of an API, right? But they can go in front of any website. And they're designed, again, to protect from things like anomalous code that might be getting in there, injection attacks, so we can define what characters are allowed to go into that application to protect it from a SQL injection attack or some other type of web attack that's out there. And then the cloud security posture management. This is designed to help our in the change control or in the production environment. So I've got an application that's running in production and it's set up, and someone goes in and makes a change, but it didn't go through the change control process, or didn't go through the DevOps process, right, the pipeline. Then we would want to get notified of that because it could be a malicious activity that's going on, and someone could be in there configuring something, and they've done it maliciously because it allows them now to create their attack or perform their attack. This is the traditional DevOps pipeline. I think everyone here probably has seen this or familiar with it. And what I've done is I've put all of these different tools up here on kind of where they sit in the pipeline. And as you can see, a lot of our tools are kind of far right. And so the idea here is, what if we shift the tools closer to the developer? Then they're going to get that information that they need to secure those vulnerabilities much quicker. And a traditional development kind of model I've put together here, where you've got a developer and then you've got all the DevOps tools here to help them deploy their application. So the developer's on the far left. A repository is where the developer would store their software code. So their code just goes, it's just like a file share. It's just kind of designed. There's a few more little pieces in there to help that repository manage it from a code level, not like a file share level. And then the build server, it would see the code in there, and when a developer makes a change, the code gets changed, the build server recognizes the change, and then it kicks off a build process. And what it does is it just takes the code out, compiles the code into an application, and then puts it on the registry, the artifact registry. So the artifact registry is where the compiled code is sitting as software ready to get deployed. The release server will pick up that deployed software and then send it out to whatever server that they need to send it out to. So I've started here with the test server. That's typically where it would start in the QA environment, and then onward and so forth. If you stacked it further out, it would be your UAT environment, and then your production environment, and maybe even if you've got blue-green or DR, you'd have it out there as well. But the idea is that the release server picks it up, drops it on the application server, and now my QA testers can go to work. And my QA testers use tools like Selenium. right? They use tools like Python to do their analysis. They aren't in there manually clicking away on all these different websites. They have scripts and automation tools to run all their testing. So the QA tester will get a notification that the application's out there, and then they're going to go and do their testing. And that testing will end up building a report, and that report gets sent back to the developer, right? And then the developer now has a report of bugs that they need to fix. Great. So the QA testers have done their job. And then the developer sends out the updated fix, and while they're working on it, we might be able to get a pen tester in to actually do the pen testing piece of it, right? And so now they're starting to attack that application and see what vulnerabilities they can find, and then they build their list of vulnerabilities and they send that over to the developer. The problem with this is these folks aren't in sync, and what the pen tester is testing may not be what the QA people are testing either, right? So the QA testers have their scripts, the pen tester has his scripts or her scripts, and so they're working on this same application but from different points of views. So the idea here is, how do we help our QA testers get involved with the security testing, that whole shift left idea? So it's the same thing, same model up here, except that I've got the Z attack proxy set up, right? The Z attack proxy is now sitting here in between my QA testers and the application, because it is a proxy. So it can proxy the traffic between my testers and the application server. So my QA testers, they'll get a notification that the application has been delivered. They go and build their QA tests, right, and run them. They get a report, and then at the same time, a report based off of the clicks and the information that they're doing, or they've created, or they're testing with. That information now gets viewed through the Z attack proxy. It creates its vulnerability report, and then sends that off to the developer. So now the developer has vulnerability information from the QA testing. And by the way, the QA testing should be great, because that's what users like us who would be out there consuming that product, we would be doing as well. We'd be clicking through the website in similar ways. So I'm going to show an example. I don't trust Darwin, so I'm not going to test him. I do have a video though of using the Z attack proxy to perform that same type of test. And I'm going to use these different tools here to support that. So Python is the scripting language. If you were in the talk yesterday with Marcus Carey, he said if you wanted to learn a language, Python's the language you want to learn for cybersecurity or for AI. But it's also a great one for cybersecurity and QA testers. It's just such a great language to just have in your tool belt. We use Selenium web browser automation. Selenium is a web browser automation tool. It's been around for many years. It's had several iterations, but it's a way that the QA testers build scripts to do their automated testing. And then the web browser will be Chrome. Z attack proxy is our proxy. And then I'm going to show how the Juice Shop, which is another OWASP tool out there for us to play with. I'm going to show how we can use Juice Shop in this example as part of the attacks. So this is the interface for OWASP ZAP. And so what I'll do is I'll walk you through kind of what these different sections are. Is this playing? That is odd. Thanks, Darwin. I'm gonna grab it real quick. I've got the regular video here.
You can practice it 10 times, and then when you get in front of
That is exactly how it
it
works.
doesn't work.
Let's see. Here we go. All right, let's try this. Oh wait, is it? Yes, and it's moving now. So there we go. Okay, so this is the OWASP interface. You see on there's the websites. So this is where you'll see information showing up on the website, and then you'll see the alerts as well. So as we run these scripts, pay attention to those two windows. And then I'm also going to bring up the juice shop. So this is the OWASP juice shop, and it's designed to with a bunch of vulnerabilities in it already, and it's for people who want to go and try to do penetration testing. It's a great tool for them to practice on, and it's safe to practice on. The other great thing about juice shop is it has a scoreboard. So as we go through our testing of these vulnerabilities, we'll see the scoreboard populate with all the vulnerabilities that we've actually found through the tests. So I've got some scripts here. These are Python scripts, and they're designed to just run a few of the different tests. And then you can see here, this is the IP address. So I tell it what the server is, and that's the server that the juice shop is living on. So I'm going to run that. So I bring up a command, run that, I bring up a command window. And this would be very similar to what a QA tester would have. They're going to have a bunch of scripts in a directory like this, and then they're just going to run the scripts. So we're going to run solutions.py, and then you'll see a whole bunch of stuff happen. So with the juice shop, you see the celebrations already begun. I've started to find all the vulnerabilities, and each one of those little green bars back there is an indication of the vulnerabilities. You see in the alert section down at the bottom, all of those vulnerabilities are starting to show up from the testing, and then at the top you see the websites that are being accessed by this platform or by the testing tools. And this runs for a good bit too, so it's kind of neat that you get to see it populating in real time. And this is a cross-site scripting test right here, so it actually succeeded in the cross-site scripting. And then, as you can see at the bottom here, it says that it's been completed. So here's the alerts. And the other nice thing about this is the alerts are here, and I'll show you the report in just a second. But if we click back through all the different attacks that we were successful against the juice shop, we'll close out all these windows, and then we'll see what our score is. And 28%. Now, juice shop is not an easy tool to attack. There's a lot of different vulnerabilities that are in it. But so I just wanted to show you an example of just how the vulnerabilities from juice shop get picked up by ZAP. And then what we do is we can build a report. So this report gets generated, and this is what we would actually send to our developers. So we click Generate Report, and it'll pull up a nice template here. It's a templatized report, but it'll get filled out with all the different vulnerabilities that were discovered.
It caught 28% of the vulnerabilities on the juice app.
On the juice shop website.
So it missed a bunch then, right?
It does miss a bunch, yeah.
Okay.
I wasn't going to fill out I wasn't going to run all the scripts.
Oh,
Yeah.
you keep digging at
You
it.
keep attacking. Yeah, you can keep attacking and learning. It is a learning tool. The juice shop's a training tool. So here's some of the vulnerabilities that are in here, and I'll click on one of them. The nice thing about these vulnerabilities is it takes you to the CWE, which is the Common Web Enumerator on MITRE. So if we'll open up the website there and look at it, the great thing about this, the Common Weakness Enumeration, it tells the developer what the issue is. And in a lot of cases, it even has code in there, example code that the developer can use to solve that particular vulnerability. So it's a really nice way to just kind of merge some different tools together that are out there that are publicly available, like the library of the CWEs and MITRE. And then here's another one as well that I'll bring up, and this is which one is this? Permissions, privileges, and access control. So once again, just another view of the MITRE CWE, and we would use this information to address the development vulnerabilities. So that is the end of the demo. So we'll move on. Oh, of course you're going to work now, right? Oh, there we go. So as a follow-up, there are a lot of benefits to shift left security. Making sure that we put the tools closer to the developer, and that's the whole intention of this presentation. Tools like ZAP. There's a ton of tools that are out there from the application AppSec providers or partners that we have there that also can be inserted in these locations. So just as you're working through building out your development pipelines, consider shift left security because it will improve the security. It's going to reduce the cost and resource time of the developers in making sure that they address those vulnerabilities and fix them. It's faster development and deployment. The cross-functional collaboration is, again, a tremendous benefit that we all want to have to build the culture of collaboration within our organizations, which I think we all would love to have more of. Higher quality software is delivered because it has fewer vulnerabilities, it's less prone to attacks. And then, of course, we have increased reputation with our customers, making sure that our customers have a great experience with the tools, the applications that we have and that we deliver. And if you have a compliance, if you're in an industry or you have regulatory compliance with your company, then this also improves or ensures that compliance for your organization. Thank you all. Are there any questions? Yes?
The scripts you ran, are those custom scripts that you write, or are those provided by ZAP?
Those scripts I took off of another GitHub site. Another person had created those scripts. They're out there on the web. I can share them with you. They're all under the MIT licensing. So yeah.
Are they like generic for any website, or are they specific for use shop?
You saw on that. They might work for other websites. These were in particular for Juice Shop. All I had to do was change the IP address of the website, and then it just took the scripts and launched them. So you can definitely try it against some other sites too. Yeah.
So when you're showing that you're moving the QA team to point at the ZAP proxy,
yeah.
Are you intending for the QA team to run these scripts, or are they more like
no
their standard process? And then that's when you trigger things in ZAP.
Right. So QA has their own scripts, and we want them to run their own scripts. What I showed here were example scripts just to show what it would be like going through a website. But our QA folks, they're going to run their own tests, and those tests could go through the proxy, and you're going to see the similar results, those alerts that were showing up.
Okay, and so the scripts that they're running, I mean, they're not necessarily security focused, right? They're just
Correct.
literally looking. Okay.
Correct. So they just click through, but you'll see the vulnerabilities show up as they're going through their tests, right? Yeah. Well, I don't want to keep anyone here. I'm not going to be in between you and the prizes at the end of the day. So thank you all for coming. Thanks for listening, and I appreciate all the questions.